Now that we've seen how to create vectors and matrices, let's go ahead and see how we can use them. Matlab will evaluate the function on every element and return a vector or matrix with the same dimensions. For example, x is a vector with every integer between -2 and 3. ABS of x gives the absolute value of every element of x. Similarly, sin of x gives the sign of every element of x. I can use any of the basic elementary functions on the vector as I would use on a scalar. Let's say we have two scalars, a and b. A is 2 and b is 3. Any of the basic arithmetic operations on scalars produce the obvious results. For matrices, all these operations can be carried out in a matrix sense. For matrices, all these operations can be carried out in a matrix sense, that is, according to the rules of matrix algebra, or array sense, which is element-wise. Addition and subtraction are identical in the matrix and the array senses and defined only for matrices with the same dimension. The product A times B is the result of matrix multiplication defined only when the number of columns of A and the number of rows of B are the same. The backslash and the forward slash define the solutions of the linear systems. A backslash B is the solution x of ax equals b, and a forward slash b is the solution x of xa equals b. For example, A is a 2 by 2 matrix, 1, 2, 3, 4, and B is a 2 by 2 matrix with all ones. A plus B and A minus B are the element-wise addition and subtraction. A times B is the matrix multiplication. A backslash B gives the solution of the system A times x equals B. For all the element-wise operators, we use dot preceding the operation. A dot star B gives the element-wise multiplication of the elements of A and B. A dot slash B gives the element-wise divisions of the elements of A and B. For the vectors, we have special products which are the dot and cross products. They can be found using the functions dot and cross. For example, let's create vectors I and j representing the unit x and y axis in 3D space. The dot product of I and j given by dot of I and j is 0, as it should be because the x and y axes are perpendicular, and the cross product of I and j gives the unit z-axis. The conjugate transpose of a matrix or a vector A is given by A prime. If A is a real matrix, then A prime would just be the transpose. Let's say A is a rectangular matrix of dimensions 2 by 3. A prime is another matrix of dimensions 3 by 2 with its rows being the columns of A. The functional alternatives for conjugate transpose and transpose are C transpose and transpose respectively. For example, transpose of A gives the same result as A prime. As discussed earlier, most functions that act on a scalar can be given a matrix argument, in which case the functions are computed element-wise. Here, square root of A computes the element-wise square root of A. But say you wanted to find the matrix B such that B squared is A, that is, the square root in the matrix sense. The function you would want to use would be sqrtm. We can check that B squared is in fact A. It might just be helpful to know that functions of a matrix in the linear algebra sense are signified by names ending in m. For example, log m, square root m, exp m, etc.